Hi. In this video, we're going to explore power series and to determine which values of x the power series converges. All right, so first, what is a power series? Well, we're going to write it first, a power series centered at 0. Okay, so a power series centered, which I'll explain to you what that means in a minute, centered at x equals 0 is of the form summation n equals 0 to infinity c sub n x to the n. And that coefficient right there, c sub n, just means it changes for every n. Or it could stay the same, but it doesn't have to. So what this would expand to would be c sub 0, x to the 0, plus c sub 1, x to the 1, plus c sub 2, x squared, and so on. The nth term of this series is c sub n, x to the n, and it goes on forever. Okay, so note that subscript just means it's a naming device. So c sub 2 just says, hey, that's the constant that's in front of the x squared term. Okay? All right. Let's look at an example or a couple examples of a power series centered at 0. We have 3 to the n, x to the n. Okay, this is a power series centered at 0. We'll start at 0. This 3 to the n is my c sub n, and if I were to expand it out, it would be 3 to the 0, x to the 0, plus 3 to the 1, x to the 1, plus 3 squared, x squared, and so on. The nth term would be 3 to the n, x to the n, as is indicated in the series. Okay, so that's an example. Let's do one more. I could say x equals 0, I'm sorry, not x, n equals 0 to infinity, and this time I'm going to say 2x to the n over n plus 1 factorial. Okay, so note that this piece right here is my, well, let's draw it a little bit better. That's my c sub n. All right, so if I were to expand this, this would be 2 over 0 plus 1 factorial x to the 0 plus 2 over 1 plus 1, I'll write it out like that, factorial x to the 1 plus 2 over, what are we at, 2 plus 1 factorial x squared, and so on. Okay, you could simplify that. That really is just 2 plus x plus 2 over 3 factorial x squared, and so on. Okay, so that's just a power series centered at 0. More generally, a power series centered at a, or at x equals a, is of the form c sub n, that's just the coefficient, x minus a to the n, and starting at 0 to infinity. So when you expand that, it's c sub 0 plus c1 x minus a plus c2 x minus a squared. So it looks just like before, except instead of x to the power, it's a shift of x. And all your x's are shifted by the same factor of a. Okay? Now I want you to notice something, that the big question that we have, as I said earlier, is for which values of x does a power series converge? That's the big question. Well, one thing I want you to notice So let's look at our general form. If we have c sub n x minus a to the n equals 0 to infinity, without knowing anything else about those coefficients, which really makes or breaks our convergence, note that when x is equal to a, so that particular x value, this series becomes the sum of c sub n of a minus a, or just 0, right? Or a sum of a constant times 0, which is just a sum of a bunch of zeros, infinitely many, which is 0. That's a number less than infinity, so our series converges when x is equal to a, and that's for every power series. Okay, so let me just recap that statement. So when our power series is this, we know that this power series will converge for x equals a. We know that. Okay? But the other question is for what other values of x does this series converge? And you'll have to watch the next video to find that out.